Thank you. I assume this is working, yeah? Can you all hear me pretty well? Cool. Yeah, thanks for coming to this session. So what we're going to focus on is on how Snyk treats app security within the Azure platform. But I just want to be clear before I get started, like from a Snyk perspective and AppSec perspective, we're kind of cloud agnostic, AWS, you know, there's Azure, GCP, or on-prem, right? So you'll see that as part of this presentation. I am a principal solution engineer here at Snyk within the whole APJ region. I'm from Melbourne, Australia as well. So what we're going to do in this talk is going to do about 10, 15 minutes of slides and then some demos, right? So we're going to see what it means for a developer who's building applications on the Azure platform. What are some of the integration points? And for what we're going to do here, we're going to be looking at an application that's running all the way on AKS in Kubernetes, right? So we're just going to look at exactly what it means while he's in his IDE, where he's testing in his container registry, and all the different CLI tests he can run, as well as pick up applications on Kubernetes as they automatically hit the cluster. I don't know if we can ask questions here, so whether we leave it to the end, I don't mind. So maybe we can leave it to the end, or if you've got questions, feel free to ask. I'm just going to go through what is Snyk really quick. Does anyone heard of Snyk? Okay, cool. So maybe someone can come up and do it. Who wants to? Anyway, no. So just really quickly do what is Snyk, just so that we can level set in terms of what AppSec means from a Snyk perspective. I'm then also going to talk about how Snyk fits into the Microsoft ecosystem, right? So we're going to look at end-to-end, how a developer can run various tests using the Microsoft platform, if you like. And then we're going to do various demos using that ecosystem, and someone's going to tell me when we've got 5 minutes left, but we will be finished in about 25 minutes. So, and Q&A. So what is Snyk? When we talk about AppSec, we're talking about how do we fit into the developer's software development lifecycle so that they can take ownership of security and test all the way through from when they're in their IDE all the way into an app running in Kubernetes. And what's important to understand here is the repo is almost like the system of truth in terms of what an application is in production. So all your configuration files should be in the repo, from the IAC to your Docker file that's creating the container image to your source code and even your open source manifest files. So that's why we have 4 distinct products that covers all of that from an AppSec perspective. Snyk code being the code that you write itself, which is SAS scanning. Snyk open source is the manifest files, depending on what it is, if it's Java, a pom.xml, or a build.gradle. If it's Node, it's a package.json, for example. Snyk container then goes and tests the application in a container image itself, right? So we're testing for Linux vulnerabilities, but also the application components, right? A container on its own is typically stateless, but it's going to have application artifacts in there. So your web app, it'll be your API, your web app, whatever it needs to be. I'm going to show you how Snyk goes into the container to show you the open source vulnerabilities, not just the Linux vulnerabilities itself as well. And then we're going to look at IAC as well, where we're testing infrastructure as code. In this case, with Microsoft, it could be Kubernetes YAML, it could be Terraform, or it could be ARM templates, or even Bicep, right? So we can do all of that stuff as well. So that's the platform in a whole, and it's all backed by our own security intelligence database. We do get data from multiple sources, but ultimately we own our database and our intelligence, and our customers then utilize that intelligence, not just for remediation advice or the vulnerabilities, but also the remediation advice as well. Okay, so this slide best summarizes, I'm just going to build it out. Hopefully not go to the next one. This summarizes exactly what we do on the Azure platform. So from a coding perspective, I'm going to show you in VS Code how a developer can actually run tests. And there they'll run SCA, software composition analysis, or open source scans, as well as SAS scans as well. So I'm going to show you we're going to be using this one Spring Boot app. If you're wondering, Microsoft Spring Boot, ultimately the platform will run any type of app, right? So, and Spring Boot's pretty popular, so we'll focus on that. From a source code management perspective, we can integrate into any Git-based source code management system. We're going to focus on Azure repos and GitHub in this demo itself because they're Microsoft. CI/CD, we can use GitHub Actions or Azure pipelines. I'm going to show you in an Azure pipeline what testing our full 4 products in one pipeline and how we can visualize what vulnerabilities exist in that pipeline as well. So the code, the open source manifest files, the IAC files, and the container Docker files, well, all tested in a pipeline that gives you the ability to break a build if you needed to. The other one is the container registry. So we're going to test Azure Container Registry directly, but we can connect to any container registry. And then in production, we're running Kubernetes AKS, and these apps are then, this Spring Boot app is running in Kubernetes. We're going to deploy that app and watch how Snyk automatically picks up that app and starts scanning it for vulnerabilities. Now, typically you'll do this well before it makes its way to Kubernetes, but if you understand how vulnerabilities work, over time, vulnerabilities can then surface. There may be zero when you actually deploy the app, but over time, vulnerabilities can then appear. And so what you want is that feedback loop so that when you're in Kubernetes and vulnerabilities are appearing, you're going all the way back to the devs and say, fix this in your Docker file, fix this in your code, fix this in your open source file, redeploy the container image and roll out a new version, right? That's what we mean by that continuous loop. So we, from a Microsoft perspective with Snyk, cover the whole software development lifecycle itself, right? Except for we don't scan virtual machines, right? So, all right, so here's just a couple of things of what we're going to do. So we're going to go through IDE integrations a little, and Ryan's just put up there the importance of giving the developers or empowering the developers to run scans well before they commit or merge code, right? So give them the ability to fix it, and we'll show that in the demo itself. The real cool part of this demo is I'm going to show you an Azure DevOps pipeline. I'm going to show you exactly how we embed Snyk into that pipeline to run the different types of tests. In fact, it's my favorite CI/CD tool, Azure DevOps, but given that Microsoft now own GitHub, I don't know if that's going to last much longer, right? But to me, it's the most flexible one. And I mean, I've used Harness and like Harness now is CD as well. But I find Azure DevOps the most powerful run in terms of, so we're going to see what that looks like. We'll actually kick off a pipeline, but we're not going to wait for it to finish run because it takes about 4 minutes, but I'll show you the output of what it looks like once it's run, right? What I want you to gather from this talk, though, is no matter what I'm doing, whether it's in the IDE, in a pipeline, scanning a container inside a registry, this is all done in minutes, or if not, like less than a minute. So it's all quick. No one needs to wait months before we get everything set up, right? It's really, really easy to integrate. It's probably the number one feedback I get from customers that use the Snyk platform is how quick they can get up and running and run scans. The next part is then how quick can they then remediate. That remediation device is there. They can create pull requests or they can easily fix it because the data's there for them to fix it. So got a customer here that keeps nodding his head. I'm only going to be worried when he nods the other way. No, pass, no. Right, but right now he's nodding like this, so we're all good. Yeah. So the container registry is an interesting one because I get from a lot of customers that we're already doing container scanning, right? So what does that mean, right? So to scan a container for Linux vulnerabilities is one thing, but to get a more appropriate container base image to use is where Snyk shines. It gives you that, it allows you then to hook into the Docker file, change it and update it. The devs do barely nothing. The pull request is created automatically for them. They just need to test, verify and merge it, right? So that container registry scanning, in terms of scanning container images, the most important part is not just the base image, but also the open source vulnerabilities that make their way into the container through the app, right? Because that's what stateless apps are, there's application components in the container. So we'll see that as part of the demo as well. And then the last part of the demo is an app running on AKS. We support all the Kubernetes distributions, so GKE, EKS. We don't support, anyone here a huge AWS fan? Hopefully not if you're in here. We don't support ECS, right? So if you're wondering why, it's pretty straightforward because Amazon decided to create their own container solution. Kubernetes came out and they thought, oops. Anyway, so they have EKS and they have ECS, but we don't support ECS, right? So, and you're going to see here, and you look at this screenshot here, how we scan into a container and we're scanning the base image itself, as well as the open source libraries. And this is where you'll see how Snyk makes it really easy for the developers or security practitioners to go and see where the issue is and what needs to be fixed where. And then because we're integrating into Azure repos or into GitHub, we can easily go and fix it for them as well. I wanted to bring this up. I don't work for Snyk, but Snyk is a partner of ours. And someone, so Snyk here or Snyk user? No, ah, nice. I like your somewhat hoodie, but yeah, it looks good. No. So what I'm showing here is end-to-end what it looks like to Snyk source to run, right? So the whole ability for you as a developer to be able to test while you're in an IDE, while you're on the file system, be able to scan directly in the container registry, all the way to when it hits a Kubernetes cluster and scan while it hits the Kubernetes cluster is really powerful. The reason I want to bring up Snyk here is that if one thing you've learned from the 10 minutes I've been up on stage is we don't do runtime, right? For us, it's all around fixing it before it gets to production, right? But I am going to show you there is a caveat there about how while an app's in production, we are scanning that image regularly so that we're giving you the ability to fix it, right? But we don't go and see who logged into the Kubernetes cluster, what sort of malicious activity happened in the VM. We don't do that, but our friends at Snyk do that plus a lot more, right? So in terms of policy management and all that. So it's a really, really cool story. So it's part of this demo, we're not going to see Snyk, but this is what you're going to see in the demo, end-to-end, a developer who's got code in their repo, who then creates the container image and will scan that in the registry to deploys it on Kubernetes and get it automatically picked up itself. Any questions on the demo before we move to the demo? Does that kind of does this image clear? Holistically from a Snyk platform, we want to capture all these data at all these different integration points, right? That's what we're doing from a platform perspective. So that a security practitioner can come in and he can say, right, this log for J issue, this 0-day vulnerability came out, it's 24 hours later, is there a fix? And if there's a fix, give me all the projects that are running in Kubernetes or in their repo based on the CVE, and I'm going to go to the developers to tell them to fix it. And conveniently, Snyk has already created the pull request for me to fix it, right? So that's the power. And all that can only happen with this integration end-to-end, right? Any questions before we go to a demo? Either I'm making sense or I'm not, right? So we can go to questions at the end. So live demos with this little person with a carrot at the end of their laptop. Hopefully that makes sense. What I am going to do is before we go there, just make sure. Yeah, is that big enough, or do I need to command plus once more? Just, yes? One more? Okay, one more for you guys is great, is painful for me. How's that? One more? No. So I'm going to have to go to here, and I'm going to have to go to here. How are we going for time? Still 10 minutes? 15 minutes, wow, cool, we can talk about anything then. So what I'm going to do here is just make sure, no, not this one here. Just make sure this is big enough as well. Is that big enough? Okay, yeah, that's too big, Pass. All right, cool. So this is the Snyk platform, and part of the demo we're going to go through this. This is our Snyk app UI. And from here, we can have a look at all those different tests, right? So if you can see here, along the left-hand side here, it's called Microsoft New. This is just an organization within Snyk. We can have multiple organizations. So you can have different feature teams using different organizations within Snyk, and then the security practitioners as a whole overseeing what's happening across your organization, right? So this is, think of Microsoft New as a feature team building apps on Microsoft. And you can see here we've got different integrations here. So if I just wanted to look at what was happening in ACR, for example, you can see here that I've got various different container images that I'm scanning directly from ACR. That's that little icon there is the ACR icon. And if I just wanted to look at, okay, what about my source code management, Azure repos or GitHub? Same sort of thing. This time I'm now just looking at the repo. So I'm going to show you what all this means, and if I just want to see what's happening in Kubernetes, I can click on Kubernetes. The reason I brought this up first was because the last screenshot that holistically showed this shows all those different integration points. So the first part I'm going to start with is I'm going to go to VS Code because this is a Microsoft presentation, but typically I'd use IntelliJ for a Spring Boot app, but let's just go to VS Code for today. So this is this big enough? At least the middle part is. I'm not sure how to make the rest bigger. This is my app itself, and if I wanted to install this little Snyk plugin here, I can now just run this little plus symbol here, and I can automatically start scanning for vulnerabilities. and also code issues as well, right? So you can see this scan's happening at the back of me hitting that little plus symbol, right? If I went to a terminal window for this, how about we just go to, just got to remember where I put this. So Snyk, projects, Snyk boot app. This is that same app here, right? So I could just run a Snyk test here, right? So running a Snyk test is, I'm saying I want to run an open source test here. If I want to run a SAS test, I'll run a Snyk code test, right? But ideally, it's much easier. And you can see here all the vulnerabilities are listed. I'm going to show you in the UI because it's a lot easier to see. But these are all my vulnerabilities based on the open source libraries that I selected in my pom.xml, right? So there's quite a few in there, right? The key is, how do I go about fixing these? And the easiest way to see that is in the UI itself, even though it's telling me here. So if I go to back to our VS Code, that's that same scan on the pom.xml there, right? So you can see here we've got this log4j issue here. This is that 0-day vulnerability that came out 6 months ago. So I deliberately put it in there, not by chance that you're seeing it. And on the right-hand side, it's a remote code execution. It's got a CWE, a CVE. All these are clickable links. And we've also got this ability to go to this Snyk Learn module, which will automatically take us to a module and start for the developer or even a security practitioner to see what the implications are if they don't fix this issue, right? So Snyk Learn is all around empowering developers to understand why this vulnerability needs to be fixed first. And then Snyk itself is showing you exactly how to fix it, right? So it's saying that it's introduced through this version that you've got inside your pom.xml, and it's fixed in this version. You may be wondering, okay, so I can fix it now. What I really want is a fix button, right? We don't have that in the IDE at the moment. So what I'm going to do is switch over to the UI, and in Azure repos here, if I go to Snyk boot web app, what you'll notice first before we actually go to that is we've ran the different types of scans based on the repo. Remember how I was telling you in the repo should have all your application artifacts. Your IAC files should be in there. Your Docker files or Docker files should be in there. You'll see all those individual scans are exactly that, right? So we've done a SAS scan. We've found our Docker file. We've scanned that. We've found some Kubernetes YAML file, which is IAC. So I'm not using, there is a Terraform file in here, but I'm not using that. And it found the pom.xml. So if I go to the pom.xml itself here, you can clearly see that we're identifying all these issues, and then we're giving you the ability to also fix these issues with the, so if you see there's the log4j issue, we can fix this vulnerability opening up a pull request directly, right? So if I was to click on that. So you can't do it from the IDE because the IDE isn't integrated to Git. You've already cloned it, it's there, right? So I can do it in here because Snyk has set up an integration, right? And so I could open a fixed pull request for this. All the different vulnerabilities appear here, but only one is actually selected, the one. So I'm going to open a fixed pull request for this. Oh, how nice of Snyk to go open up a new tab, right? So it's going to now actually create a pull request that fixes the version from one to another. And it's doing that directly on Azure repos. This works on GitHub, this works on Bitbucket Server, but ultimately what it's doing is pulling in all the information for that vulnerability into the pull request and then giving you the ability now to approve, merge, because a developer still needs to make sure that this fix isn't breaking anything else, right? Because he's going from one version to another. One of the things Snyk does though is if you've got a vulnerability in an open source library, it will go to the next safest version, not the latest version of the library, right? Very important to note that. If we go to the latest version of the library, which will most likely fix it, we then we're ultimately responsible for breaking the app here. If we've gone 5 or 6 different versions of a library, the likelihood of some method that you're using in that library having changed is high, right? So as a result of that, we want to go to the next version, the closest version, which will mean lower the risk of that. But also by going to the next version instead of the further version, we can guarantee as part of that fixed pull request that we're not introducing any more vulnerabilities. Because if we can't, we won't give you that fix this pull request, fix this issue via a pull request. So I'm going to go back to projects here, but before we go back, just have a look at the container stuff. We also ran a code security scan here. So we've got this customer REST If I go in here and I've got a customer REST endpoint in here, maybe you can be a bit bigger. So you can see here, I'm actually making some calls. This is Spring Data JPA, for example. I'm making some calls here. And if I go to the customer service itself, you can see here I'm making some calls to the actual database itself using some JDBC here, Spring JDBC. But what's happened here is when Snyk did the scan, I kind of didn't write the code the way I should be writing it, and it's complaining about some unsanitized input, right? So if you're actually creating queries that are hitting a database, you want to make sure that you're not concatenating strings and that there's some sanitization happening before you actually run the query itself, right? And so this is what we call while it was number one, it could be two now, the number one OWASP SaaS security issues are SQL injections, right? So it may be number two now, but it was one for a while. So it's found that as well. But if I go all the way back to that application here and look at it from a perspective here, this is a lot nicer because it's more visual. You can see here that it's found this SQL injection. It's pointing to the line of code where it is. The Snyk Learn module that was in the IDE plugin for VS Code is also there. But the cool part is this thing called full details, right? And what's cool about this is it allows you through a data flow to work out how does a user get to this vulnerable line of code? Why did Snyk suggest that this was a SQL injection? And it's like the data flow from what we call a source to a sink, right? And so as a result of that, they can flow through. And so this could be fixed at any different various point through the code. But ultimately, getting to the line of code is one thing, and then working your way back to see where to fix it is another one. And then we have fix analysis as well. So as a result of that, we have some best practices and then some example fixes. So we're monitoring tons of open source repos, but really open source repos that are, lots of contributors, lots of users, lots of fixes, so that when we can give you intelligent SaaS fixes here, right? So there is some work taking place at Snyk so that we can actually issue pull requests on Snyk code issues, but that's a bigger program of work because ultimately then we're changing the source code itself, not just the manifest file entry, right? So that's a little harder to do. Everything that you've seen here from open source and SaaS, as a result of integrating with Azure repos or GitHub, every time there's a commit or a new pull request or a successful merge, we rerun a scan and run PR checks, right? So we will block based on PR checks that you've actually done something here to introduce more vulnerabilities, right? So that's some of the stuff that we do out of the box. So how are we going for time? 6. So let's now move to something a little more exciting, containers and Kubernetes, or maybe the first part was more exciting. That's cool. So I'm going to go to projects here. Inside here, you would have found that in this Spring Boot web app, it found a Docker file. And in the Docker file, it's just an instruction file. The Docker file is not the container itself, but it's really clear what do we want to build the image from, right? And so you can see here the base image that we chose was this OpenJDK Slim Buster. In fact, if I went to that here, you would see inside here. And if we went to the Docker file, you can see here that it's really clear in the file what we're using. And whether you're using multi-stage Docker file builds, it doesn't matter. One base image is only going to be selected at the time of when you build the image. And so that's clear, so we can easily do that. Nothing rocket science about that. That's the one that we've found. Going to our vulnerability database, there's 3 critical, 4 highs, 1 medium, and tons of low. But because we've integrated, we can actually suggest fixes that have far less issues than the one that you've actually, Linux vulnerabilities, than you've selected, right? Remember, at this point, we're only looking at the Linux vulnerabilities based on the base image, but we can open a fix pull request and fix it for you, much like we did with the open source manifest. Where it gets a little more interesting is when I go to projects here, and now I've already built this container image, and I'm going to switch to ACR. And this is that same image already built. And you'll notice now that this time, so this is V1 is the tag. This time when I select on the base image, I don't get a fixed pull request here because now I'm talking directly to the container registry, which stores OCI images. A container registry is just basically a dumb blob store. It does nothing else but store images, right? Kubernetes or any other container orchestrator, if you're unfortunate enough to use ECS, can also just pick up these images and run them, right? But in effect, it does nothing else, right? But what we can do, though, from a Snyk perspective, is still auto-detect what that base image is and still give you the remediation advice. So now you go back to your Docker file and go and fix it in the Docker file itself. These are all the different integration points as we're making our way into production. So you can see now that even though it's been built incorrectly, we still have the ability to scan the container image and verify what would be the base image that we want to fix. The other thing, the other thing that you would have noticed in here is it also did an open source scan. So it traversed the file system for Java, found some Maven jar files on the file system, and then gave us a viewpoint of all. And this will look almost similar to what we saw before, right? There's the my log4j issue, but this time it's within the container, right? So now we can go back to the developer and say, you haven't even fixed this open source issue, let's fix this, right? And so you see how I've done this at the source code. I've given the developer the ability to do it at the IDE. I've given the security practitioner developers to look at what's happening in their repos. And now I'm at the container registry, looking into the container. So and the last part that we want to look at is, if I roll out this application, which we're going to do live, right? So if this isn't already live. So what I'm going to do now is I'm going to actually deploy that V1 container that has that log4j issue, has a base image that's not quite the one that we should select. It's got way too many vulnerabilities. So I'm now just going to select Kubernetes here, right? So there's a couple of other already apps running. There's a juice shop, an employee API, pet clinic. What I'm going to do is deploy a new one. And that's going to be our Spring Boot web app, right? So the container is already been scanned in the registry, because I just showed you that, but it's not running on Kubernetes yet. So we'll switch to this terminal window, not ACR. So we'll go into Kubernetes. And to deploy this app, I'm going to use a really basic deployment YAML file. And you can see here I'm pointing to this V1 version, which is sitting in, hopefully no one saw that, in Docker Hub. It should be in ACR, but it's also in Docker Hub. But just pretend it's in ACR for now. So I'm going to do a kubectl apply -f, and we're going to deploy that to the cluster, right? So if I do a check pairs, pairs is the name of the namespace. For those wondering what check pairs actually does, it just does a kubectl get all in that namespace pairs. And you can see the Spring Boot web app is already running. It's already running because I've deployed it 6,000 times, right? This is the 6,001 time. So it's already running. And if I actually, there's already a monitor running in here, right? So I've got a, where is it here? A monitor pod somewhere here. So we've got this monitor running, which is the Snyk controller running in the Kubernetes cluster. It's just a single deployment with one pod. We've got one more minute. I promise we're going to finish. So now what I'm hoping is that as a result of deploying that, that workload automatically gets added, and there it is, Spring Boot Web, right? So this is where you're meant to clap. No. So anyway, so that's the whole purpose of the integration into Kubernetes, is it picks it up automatically for it. And then if I look at that really quickly, if I just do a refresh of that, and I go to the Spring Boot web app, and you can see here it's done the open source scan, it's done the app scan, and from here you can see that it's finding the same issues because we haven't fixed it. We really need a V2 version, right? So that was it from the demo perspective, because we are out of time. I don't know if we have time for questions, but otherwise I really appreciate you coming to this, and hopefully you learned something about Snyk. So.